So this point is x1 comma y1, this is x2 comma y2, and this point is x3 comma y3. Okay. So there are 4 different types of centers which we can have inside the triangle. Okay. I'll discuss one by one. What all are these? First one is a centroid. Okay. Second one is a circumcenter. Okay. Third one is the incenter, and the last one is orthocenter. Okay. If you remember these points in this pattern or in this order, it will be very easy. I'll show you how. Okay. So first, let's study what this point is denoted by. Okay. This point is usually marked by G, this point by O, this point by I, and this point by H. Okay. So we'll follow this convention. Okay. This is very common convention which is followed in case of all these points. Okay. So first, let's see what is the centroid. Okay. Centroid is this point G. Okay. So first, let's discuss what is centroid. How do we get the centroid? Okay. Centroid is nothing but the point of intersection of all the medians. All the medians, the point of intersection of all the medians. Okay. Now what is a median? A median is a point from here, okay, which divides the other line. Okay. If we have this line, okay, now it divides the other line. It starts from this vertex and it divides the line opposite to the vertex. Okay. Then this will be the median. Now we are going to have 3 medians inside the triangle. Okay. These 3 medians will intersect at a common point. Okay. That point will be called the centroid. Okay. Now how do we find the coordinates of this centroid? Let's study that. These coordinates can be easily written as G is equal to x1 plus x2 plus x3 upon 3, comma y1 plus y2 plus y3 upon 3. So if you know all the 3 coordinates of a triangle, you can easily calculate the coordinates of a centroid. Okay, pretty easy stuff. Let's move on to the next center, which is circumcenter. Okay, so first we need to study what is a circumcenter. Let's suppose we have the same triangle. Okay, and we have a circle outside the triangle. Okay, now this circle is called the circumcircle. The circle circumscribing a triangle is called the circumcircle. Okay, now there will be a center of the circle. Okay, now this center of the circle is called the circumcenter, and what will be its property? That the distance of this center from all the 3 points will be equal. Okay, now we can say that if this is A, this is B, this is C, and this is O, we can simply say that OA will be equal to OB is equal to OC. Okay, so by basic definition, circumcenter will be the center of the circumcenter, center of the circle circumscribing the triangle. Okay, circumscribing the triangle. Okay, so how do we find the coordinates of this circumcenter? We'll just apply distance formula. Okay, we know this coordinate x1 comma y1, and this one x2 comma y2, this is x3 comma y3. So what we are going to do is, let's assume this point is x comma y. Okay, we find that this distance OA, this is equal to under root x minus x1 ka whole square and y minus y1 ka whole square addition. Okay, so OA is equal to under root x minus x1 whole square plus y minus y1 whole square. Similarly, we know OB, this is equal to under root x minus x2 whole square plus y minus y2 whole square, and similarly we know OC. So what we are going to do is, we are going to equate OA and OB. Okay, we can simply square both sides. When we square both sides, we are going to get an equation, linear equation, in x and y. Why are we going to get a linear equation if we have this x square and y square term? Because we're going to get x square term over here, y square term over here. Similarly, x square term over here, y square term over here, and which are going to cancel out. Okay, which we'll study later in the questions. Okay. Similarly, we get one equation from here. Okay, one equation we're going to get from here. OA is equal to OB. Similarly, next will be from here. OB square is equal to OC square. Okay. Similarly, we get two equations in x and y, which we solve, which when solved will give us the circumcenter. Okay. So let's see the next center, which is the incenter. Now incenter is the center of the circle which is inscribed inside the triangle. Okay. Now see the difference. Okay. This circle is inside the triangle, while that circle, okay, circumcircle was outside the triangle, touching all the vertices. Now this circle is touching all the sides. Understood? Okay. So this point is ABC. Okay. We must have studied in our lower classes that this side opposite to the vertex A can be denoted as small a. This can be denoted by small b, and this by small c. Okay. These coordinates remain the same: x1, y1, x2, y2, and x3, y3. Okay. Now I want to find the coordinates of this point x, y, which is the incenter. Now this incenter is simply given by ax1 plus bx2 plus cx3 upon a plus b plus c, comma ay1 plus by2 plus cy3 upon a plus b plus c. Okay, so these are the coordinates of this point in center. Now how are we going to calculate a, b and c? Simply by distance formula. Okay, apply the distance formula over here, here and here. Okay, put the values. We all know the coordinates of this: x1, y1, x2, y2, x3, y3, and apply this formula. You will get the incenter. Okay, there's one more term which is called in radius. Okay, how are we going to find the radius of this circle? In the case of circumcircle, we can easily find the radius once we get this circumcenter. Okay, because in that case, if we know this center and this vertex, we can simply find the distance between these 2 points and simply say that this is the circumradius. Okay. Now in this case, we want to find the in radius. Now this in radius is given by delta upon s. Okay. You must have studied in the Heron's formula, which we used to study, that this is called the semi-perimeter. Okay. This is a semi-perimeter. And this thing over here is the area. Area of triangle divided by the semi-perimeter. Okay. So I'll write it over here. Area divided by semi-perimeter will give you the value of in radius. Okay. So we can simply find the area of the triangle by Heron's formula, or if it is a right angle triangle, we can simply apply the formula half into base into perpendicular. Okay. And in case of equilateral triangle, we also have a formula. Okay. So this is the value of in center and this is the value of in radius. Okay. So in the last, we have our orthocenter. Now what is an orthocenter? Just understand, it's pretty easy stuff. If we draw all the 3 altitudes or the perpendiculars from this vertex to the opposite side, okay, if we draw all the 3 perpendiculars, they will meet at one point, which is called the orthocenter. Okay. Now the thing is, this point can be calculated by the application of straight line. Okay. So this is the application of straight lines, which we'll study in the next lecture. Okay. How to calculate the orthocenter. So bus, in this case, we'll just write that what is the definition of an orthocenter? Orthocenter is the point where all altitudes meet. Okay. So now we are familiar with all these points: circumcenter, centroid, incenter, and orthocenter. Okay. Now we are going to gather a relation between these 3 points and these 4 points. Okay, so how are we going to do that? Let's see. Now there is very fascinating thing. In case of equilateral triangle, all the four centers are at the same point. Okay, so we can say all the four centers coincide in case of an equilateral triangle. Okay, understood? So if you want to find the orthocenter of an equilateral triangle, you can simply apply the formula of centroid, which is x1 plus x2 plus x3 upon 3, y1 plus y2 plus y3 upon 3. So first you have to check, if you are asked any of these centers, first check whether the triangle is an equilateral triangle or not. If it is an equilateral triangle, you can just apply the formula for any center, okay, and you will get the value. Okay, so next thing is, there is a special property of centroid and median. Okay, if this is a median and this is a centroid, okay, this centroid divides the median in a ratio which is 2:1. Okay, 2:1. So we can write centroid divides the median in 2:1. Okay, so this value will be 2 times this value. Okay, so easily we can apply section formula or position ratio over here to find any of the coordinates. Okay, this is a very good application, and why I did this application after discussing centroid is because this 2:1 is also going to happen in some other case. Okay, let's see what that case is. This is clear to everyone. Centroid divides the median in ratio 2:1. Okay, the next thing is, if I take, this is the circumcenter O, let's say this is a centroid G, and this is the orthocenter, which is H. Now this ratio OG ratio GH always comes out to be 1:2, or we can say that GH ratio OG is 2:1. Again, this ratio 2:1 is getting introduced over here. Okay, now this happens in case of any triangle. Okay, so if you know the value of centroid and you know the value of circumcenter, you can easily find the value of orthocenter. Okay, you don't have to apply any application of straight line because we know how to calculate these 3 centers. So we can easily calculate the orthocenter in case of any triangle by using the section formula. Okay, we can easily apply the section formula. Now this thing is pretty easy. Okay, next thing, and this line has a special name. Okay, line joining these 3 points has a special name, and this is called